So I'm going to do some review of radicals, and the first thing we're going to do is to remember that if you have this property of radicals, that if you have the square root of a times b is the same as the square root of a times the square root of b. We used this a little bit already when we did we worked with complex numbers, because we wrote, remember when we did like the root of -16, we were writing this as the root of 16 times the root of -1, sorry. So this became 4, and this was an I. Yeah, so that's how we got this already with complex numbers. So I'm going to use this, but now we're not dealing with complex numbers. We're going to use this for when we want to simplify radicals. And we did this a little bit when we did some complex solutions, solutions for the quadratic formula. Some students will end up with an answer like a root of 32 and leave it like that. And other students will write this like 4 root 2. So why is this the same? Well, because if you realize, if you square this, right? If I square this number, I get the other property that we need to remember is that this is the 4 squared and the root of 2 squared, right? So the 4 squared becomes 16, and the root 2 squared, of course, becomes a 2. So that's why this is also the root of 32, because if you square this quantity, you get to 32. So that's going backwards, but how do you realize that the root of 32 can be written like that way? Well, what you do is you use this property that I have up here. You write the root of 32 happens to be the root of 16 times the root of 2. Why am I breaking it up like that? Because I know that this guy is a perfect square, right? So the trick here is to go scan through your perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on, and see which one is the biggest that fits inside your number. And if that is a factor, you can break it up like this. The root of 16 then becomes a 4, and the root of 2 stays like that. Okay, so that's how you simplify this one. So let's do another one. How about if I did the root of 75, for example? This is not a perfect square, but if you can scan through mentally your squares, this is 3 times 25, and 25 is a perfect square. So we break this one up like root of 25, root of 3. We like to write it this way because if you write it backwards, let me show you what I mean. If you write it, this is going to become 5 root 3, and we prefer this notation than having root 3 times 5. Because this gets a little bit confusing, and maybe somebody might read it like root of 35, right? So whenever we have a radical and a coefficient, we usually put the number in front of it. So even if you write in this step, if it's not true for you to write it this way, root of 3 times root of 25, that's totally fine. But once you get to the next step, try to not to write it like that. Right? Try to write it like this, okay? Because that's confusing for people to read. Okay, this is this very simple example. So let me see if I can make a new one. So I'm going to make I'm making a new page, and let's multiply some things. So pretend I want to multiply root of 8 plus 3 times root of 2. So I'll put a root of 2 in front of that. So nothing is different. You distribute as usual. This is going to become the root of 2 root of 8 plus, and again, if I write the root 2 3, that would look weird. So I'm going to write 3 root 2. Okay. So if you leave it like this, it's perfectly fine, but we would not get full credit because the idea is that you want to simplify, and this you can also put it back together. This is the root of 16, and well, the root of 16 is a nice number, right? That's 4. So if you leave it as a top, you would not get full credit. You need to simplify this further down. This would be your answer. If you leave it like that, you're showing us that you don't know how to simplify. Okay, and in this section we want you to use this property that you can have 2 roots separated or together, depending on which helps you simplify. Okay, I'm going to do one more example just to finish, because weird things can happen. Like I'm going to write root 2 plus 4 times root 2 minus 4. So again, nothing new, just multiply as usual. Root 2 though is going to be, hope you see that this is a 2, right? It's root 2 squared, so that's just a 2. You can see that also if you write like root 2 is the same as the root of 4, right? You put inside the 2 times a 2. So that's the root of 4, which is of course a 2. So there's many ways to explain why this is 2, but root 2 squared is 2. Okay, so then I'm going to do the root 2 times the negative 4. That becomes negative 4 root 2. And I'm going to do the 4 times the root 2. That is the positive 4 root 2. And now I do the 4 times the negative 4, so minus 16. So what happened? Well, these two guys in the middle cancel, right? And this is just 2 minus 16, which is negative 14. So when you multiply a binomial, which one has a root by, we call this the conjugate, because this one has a plus, this one has a minus. So this is a pair of conjugates. That's the way we call it, conjugate binomials. Then this happens, the root cancels. Okay. Notice that it's not the same. If you square this, many students have the misunderstanding that this quantity squared would have no roots. But it will, because we'll work this out, and you do have roots. The one method where you cancel the roots is if you multiply by the conjugate, not if you square. Okay,